We will actually start. So thank you very much, everybody who is on the call today, and anybody else who happens to be listening to this at any point in the future. Thank you for joining us. But an even bigger thank you to Ofelia and her team for getting up so early in the morning to give us this presentation. It's greatly appreciated. So Ofelia will be talking today, and she's very kindly put it on the screen in front of me. First comprehensive study of the state of environmental pollution in the region of Lagunera, have I pronounced that correctly? In Mexico, or Mexico, sorry, and its possible impacts on human health. So without further ado, Ofelia, thank you very much indeed.
Okay, good night for some of you, good evening for most of you, and good morning in America. Okay, this is the project. We are going to present the results from 3 years that we worked in this project. This is the team. This is part of the team, the main part of the team that we work together. We are researchers from different universities in Mexico, and we are all here, and we are going to explain, each of us, we are going to explain you the results from this project. First, I want to say that we began this talk in Athens, in the terrace of Gillian's hotel. Do you remember, Gillian? And a very nice night in Athens. And at the night, I explained you that research teams adquired academic commitment with the government of Mexico to work in a big project. And before I introduce you my team, I want to explain what is the project, what was the problem, what we did, and the results. Okay. The 6 years ago, the government of Mexico, together with the National Council of Science and Technology, implemented a program to evaluate the pollution degree in different areas in Mexico related to industrial activity. One of this project is this project, and is related to the assessment of the pollution state in la Region Lagunera in Mexico, and its possible impacts to human health. We met, the team we met, and we worked together at the beginning to recognize different problems, environmental problems related to organic and to anthropogenic sources. And we recognized 4 big problems. One related to the environmental and public health problems in Torreon. Torreon is the main city in this area, related to metallurgical activities. This part of the project was done in my group in the Universidad Nacional Autónoma de Mexico. Another very important problem is related to the human exposure assessment to arsenic. And this was done by the local university, the Universidad Juárez del Estado de Durango. This group works since many years in this problem. They have very, very good results, and we are still working in this problem. Another one is related to the groundwater quality and the risk communication from this problem, and was done at the Universidad Autónoma de San Luis Potosí. The first problem that we recognize here is related to the pesticides and groundwater and urine of inhabitants of the Region Lagunera. The Region Lagunera is around Torreon, the main city there, and it was apart from this part was done at the Universidad Autónoma de Yucatán. Okay, related to my part, to the environmental problem in the urban area of Torreon. I show you where is Torreon. Torreon is in the north from Mexico. It's an important industrial city in the north from Mexico. And around Torreon is the Región Lagunera, or the Comarca Lagunera. Torreon had a very important, very fast economic growth and industrial development associated with lead smelters in the area, with the establishment for smelter there around 19,000. This foundation was passed in this fact, and now the city, about 120 years later, comes with about 700,000 inhabitants. Metmex Peñoles is the name from these facilities, and is in the now is in the sites from the city. This is the slags from the metallurgical activities are inside of the city. Metmex Peñoles is now the more important, the largest lead smelter in Latin America, and is the first producer for silver and for bismuth, and a very important producer for another metals. Okay, in the activity time, and we can recognize periods of different amounts of emissions from lead. We can recognize at the beginning, the first 60 years, about the first 60 years, time without control. And now, since about 25 years, we have a strict control period related to the installation of filter systems. The lead emitted in the atmosphere in Torreon, or all the time, is about 25,000 tons. The emission declined, and now it's about 12 tons per year. But the content of the levels of lead in the atmospheric environment from Torreon is about 2 or 3 times higher as the standards from US EPA. Does represent a very important problem to health in the region. Okay, we in the last 25 years, 30 years, a lot of information related to this problem is being reported, but the most of the information is related to lead. And then the objective of this study was to do a multi-elemental study of the concentration from metals and PMs collected inside of the city to, and with this data, evaluate the possible impact on health in the inhabitants of Torreon. What we did, we analyzed metals in PM samples collected the year 2016 and samples collected between 2023 and 24. And with these results, we calculate the risk indices to estimate non-carcinogenic and cancerogenic risk for children and for adults. We have here the results. We analyzed these elements and PM samples from 2 periods of times. We report here the medians from the concentration, in this case, the maximum and the minimal values, and we compare the concentration with the limits recommended by EPA and by the World Health Organization. The values underlined are values that are about this recommended limits. We see that for all samples for which we have recommended limits, in this case from 2016, and for all samples we have a concentration about this limit. It's not the case for the another period, it's a little bit better. And the values in green represent the cases when the concentration decrease, and the ones in red when the concentration increase. We have a special reduction. We see a special reduction from the concentration between these 2 periods for zinc, for arsenic, and for lead. And with this data, we calculate the indices for non-cancerogenic and cancerogenic risk. We have here in these tables for all these elements the calculated indices for the 2 periods of time. And the shaded values represent the values classified as risky. We can see that many elements in this period, many elements are about can be considered as risky in the atmospheric environment from Torreon. And when the concentration decline, we have the reduction from the concentration result, and there are now some elements that cannot be longer considered as risky. This is the case for arsenic and for cadmium. For arsenic and for cadmium. Okay, as conclusion, from this part, we can say that it is evident that the developments, the industrial development from Torreon had a negative effect in health and in the environment in the urban area. Okay, the results from this study, the multi-elemental study that we done, generate information from another methods that we didn't know they are in very high concentration in the area. And the evaluation from the indices of risk, health risk, show that there are many elements that from the analyzed elements that can be, they have a designation from carcinogenic or not cancerogenic. We are trying to organize a second part for this from this project, and we hope that this result can be used to recommend legislative regulation to improve the quality of the atmospheric environment in Torreon. And I hope we have time to discuss the results at the end. And I invite now Dr. Garcia Vargas to present his results.
Okay. Okay, thank you, Ofelia. So we are going to show you now the epidemiological part of this study, basically addressed to arsenic, because arsenic, the next please, the arsenic is present in the aquifers of the Region Lagunera. Javier Castro will talk much more about this, but since the 1950s, we start to have medical evidence that we have hydroarsenisis in the Region Lagunera. Hydroarsenisis is basically is chronic poisoning to arsenic due to arsenic in drinking water. So we start to recognize this problem in the 50s of the last century. In the 70s, also from the last century, the Ministry of Health documented chronic endemic hydroarsenisis in Region Lagunera, so was officially recognized. In the 86, the government started a surveillance epidemiological program, but the results obtained were not published, but we knew that about the arsenic in urine concentration during this time was over 370 micrograms per liter, and also water was over 100 micrograms per liter. So for this reason, in the 88, the government started also a water distribution pipe network, and the epidemiological problem was suspended, but this network of water distribution is still continuous with many changes, but still is the base of the distribution of water in the rural areas mainly. Next, please. So what we are worried about arsenic in drinking water is because increase the risk for diabetes mellitus type 2, reproductive alteration in young people, cognitive problems in children that we have also demonstrated in our region, cardiovascular issues like coronary disease and peripheral vascular insufficiency, cancer of skin, bladder, lung, kidney are the mainly associated with the arsenic exposure. Next, please. So the aim of our study was to develop and try a protocol for diagnosis, medical treatment, monitoring, recovering, and surveillance of residents and former residents exposed to inorganic arsenic. We almost know we don't have organic arsenic. It's basically inorganic arsenic, the way that we are exposed. And the idea was that this program can be useful for make public policies in health. The next, please. For this program, in the algorithms to take decisions, we took two limits that are important. One is 35 micrograms per liter, that we took this limit from the CDC in USA, and also for the Chilean experience, that they had already working epidemiological surveillance program for the populations. And 100 micrograms per liter as a clear toxicity level, and between 35 and 99 micrograms per liter is considered as a high exposure level, but it is a medium exposure level, different to 100 micrograms as a clear toxic concentrations in urine. So we use urine as the primary biomarker of exposure to work in our program. Next, please. We select 10 populations. Next, please. The area in the Region Lagunera is very wide. So we are a big valley with three main cities that are Lerdo, Gómez Palacio, and Torreon. Torreon is the main city of the region. So we took these cities as for the program representing urban areas, but also we are very worried about the rural areas because are where arsenic concentrations in water are much higher than in the urban areas. So we took the towns that are showed: Salamanca, Horizonte, Finisterre, Batopilas, Sofía de Arriba, San José de la Niña, Viñedo, San Lorenzo, representing the rural areas. So for the next slide, please. So for these people from these 10 communities, we invited 850 people from these communities accepted to participate with informed consent for writers. 1,104 people agreed to participate. From these people that agreed to participate, 47 of the people have arsenic concentrations below 35 micrograms per liter. This is the low exposure level. That is a good news, but 53% of the people chose high arsenic concentrations, 39 in the medium level, and 40% in the high exposure level. So 53% are hazardous arsenic exposure. So the next slide, please. This is a very heavy table. I don't want to see you in detail. I show this table because mainly in the lower rows, and we can have the levels of exposure. So the arsenic exposure as an internal biomarker of arsenic exposure is not homogeneous. For example, in the fourth column, we have Viñedo. that more than 85% of the people have high arsenic exposure, so medium and high arsenic exposure. So only 13% of the people had low exposure. However, in two columns ahead, horizonte, 70% of the people shows low arsenic exposure. So the levels of exposure are heterogeneous and change according to the levels that we have also in arsenic in water. The lower row shows arsenic in water in these villages. Also, a main word is Torreon. Then 40% of the people has arsenic concentrations over the expected or recommended values. So arsenic in urine has decreased, but arsenic exposure has decreased, but still affects a wide percent of the populations. Next, please. The conclusion is that total arsenic concentration in urine reflects arsenic concentration in water. This is a well-known knowledge, but this is to justify the use of arsenic in urine as a biomarker of exposure. More than 50% of the people living in the Region Lagunera presented arsenic concentration that might cause adverse effects. Arsenic concentrations in urine, for that reason, arsenic concentration in urine was a valuable tool for epidemiological surveillance process to design and adjust public health policies. And the level of arsenic in urine has decreased, but that also was reflected that only 3.5% of the people had arsenic skin lesions, but still the more than 50% of the people shows arsenic concentrations in urine that represents a high risk of skin cancer and also internal cancer in the exposed population. So we need to follow this problem and also to make public health policies to protect population. The next, I want to thank you. These are our collaborators in the field work. And so now I want to introduce you Dr. Javier Castro, that is talking about the behavior of aquifers in the Region Lagunera. Thank you very much.
Good morning, everybody. I hope that everybody can hear me again. I want to thank you for sharing this opportunity with us, and I want to show you a little bit for our part for the contribution for this project. And so our team concentrated mostly on groundwater. We are geologists, geochemists, and so I will focus on this part of the project. So the next, please, Ofelia.
Uy. Uy. Está.
Yeah. So as Dr. Gonzalo already told you, groundwater is a problem. It's a main issue in the Comarca Lagunera. That's an very arid region, and so people depends mostly on groundwater for tap water, for agricultural uses, and for industry. So there is a lot of wells. This is a huge area, and this huge area had so over 4,000 deep wells in production, and that is a strong competence between industry, farming, and people, no? And so for the groundwater for the people. So as the Dr. Gonzalo said, the arsenic has been an issue for more than 60 years in the Comarca Lagunera. And additionally to arsenic, there has been also fluoride has been recognized also in the groundwater. That is not an issue just from the Comarca Lagunera. That is an issue that is related to the volcanic rocks that is in the west part of Mexico, the Sierra Madre Occidental. There are rhyolitic, so felsic volcanics that usually they're richer in arsenic and fluoride, and in this, that is a big problem from this part of Mexico. So, so this is a co-occurrence of these contaminants represent an additional challenge to the quality. And so, as Dr. Gonzalo showed you, this exposure, especially for arsenic, has been well documented. And for rural communities, that is a bigger issue than in the cities. The next one, please. And so our team was focused on to evaluate the state of the groundwater quality for the Comarca Lagunera, and try to find some of the sources of the groundwater. There's a lot of studies, but the studies had main proposed sources, but not identified sources. So for the arsenic and fluoride in the groundwater. And we with toxicologists from our group, and so we are designing and developing and implementing a program to reduce exposure. So the next one, please, and the next one. And so we began with a sampling campaign and over the Comarca Lagunera. That is the black dots. There are the points for the wells, deep wells in all the Comarca Lagunera, and the blue lines. There are the deep water, the water levels. So you can see this is a huge area. In this huge area, usually the groundwater used to flow from west to east. But with this very high extraction of groundwater, it has changed on this area. As you can see on the right side, there is a former lagoon. That is the Myron Lagoon. That is the discharge from the old discharge zone from this area, and this is no longer available. So groundwater flowing had changed, and that is a problem also for the quality, because the sediments where the water is flowing is there enriched with these elements, and that was we were trying to look for. So we take the 121 samples, and I will show you some results of this sampling. Ofelia, the next one, please. That is on the left side. You can see the results for arsenic in groundwater, and you can see just from these all 121 samples, just 3 samples, that this has the blue dots, they are under the 10 microgram per liter arsenic in groundwater. From there, that means 97% of the sample wells are over this 10 microgram per liter. So you can have with this an idea how big and how the arsenic problem is in the Comarca Lagunera. And so the another colors they show you the red 10 to 25, then dark red 25 to 100, gray 10 100 to 200, and bigger the black dots there where arsenic in groundwater is bigger than 200 microgram per liter. There are some outliers on the until 1 milligram per liter or 10 milligram per liter in the left and the west side, but they are outliers. So and additionally, I can present you some fluoride in groundwater, and you can see we use the reference value in Mexican laws that they say 1 milligram per liter as a reference value, and you see 43% of the results of the sample wells are over 1 milligram per liter. So that is the problem, and you see the red and black dots there. So this the cluster in some regions that usually on the west part there are regions where the discharge zone is. That means probably the groundwater that this is the discharge zones. The sediments are richer in this area from these elements. The next one, please, Ofelia. Additionally, and that is a point that I will want to show you, we found also in some 12% of the sampled wells have additionally high uranium contents in groundwater. That's an issue that was until now not been reported, and we're reporting it because there's a point that should we have to pay more attention during the stand. And so if the people in rural communities are getting this water, not only with arsenic, but also fluoride and increasingly uranium, we have a big problem in this area. The next one, please. So just a very, very quick is just to say we analyze also rocks. We take rock samples, stream sediments, and analyze for the contents. And the red bars there, I just say this is the red bars there are arsenic values, and the volcanic rocks that you say in the middle of the samples, they're about 90 between 50 to 100 milligram per liter. Arsenic, that is milligram per liter, milligram per kilogram. We're speaking about rocks, and so that's usually this kind of rocks, they have usually 5 to 10 milligram per liter. That's about 5 times higher. Yeah, and additional some mineralizations on the red side, they had until 4,000. And these are probably the main sources for these elements and the area. So we started to look for them, and the next one show you some minerals. So they were not described until now in this area. That this is minerals from the group. There are structural similarity to phosphates. This is chernobite, xenotime, and the rare elements, phosphates and arsenites, and they have very high arsenic values. And we have documented that well in some of these volcanic rocks of the area. So this is we think this is one of the main primary sources for arsenic on the area. The next one, and for fluoride, We have mostly fluorapatite is the main carrier of the fluoride-bearing minerals. That is known for a lot of places worldwide. The fluorapatite is the main fluoride, but additionally we have found some other minerals, the biotite, that is also silicates, that when they get alteration get alterated, that liberate these elements to the groundwater. So the next one. One of our tasks was to think about how to communicate this information to the people so they take care of themselves. So as Dr. Gonzalo said, there have been some programs from the government, and they stopped them, and the results show the people that are still exposed to this arsenic water, high arsenic water. And so we started a risk communication program with the people of the area. So how does risk communication program work? So next one. So we engaged with the people, and so first we made informal, casual conversations with all the key informants. We identified the teachers. These small communities, maybe 500, 1,000, 2,000 people. And the schools are a very, very important focus of activities in these places. And so we focus on with the schools, and then the teachers, the kids on the schools, and on all the fathers and mothers of these kids. And we began with casual conversations and identify what do they know about this problem. And so we identified some areas that we can explore. And so what are the doubts? What do they know about knowledge? The knowledge of water contaminants, health risk, and if there are interests. So that is a very important point. Not always all the people are interested in participate. So with this information, we design questionnaires and began with testing and validation these questionnaires about the information that should be explained to the people. The next one. And so with the questionnaires, they were applied to the teachers, parents, and children from first one community it's called Salamanca. This is a community with a very high arsenic values, so 200, 150, 200 microgram per liter in groundwater, and began these interviews just to know what they know, no? And this information was transcribed, analyzed. So the adults, do they know that the water contains arsenic? Yeah, but they know that arsenic is harmful, uh, and that is produce some problems, yeah, but they don't know how much about how to deal with it. For the children, they don't know this problem. The arsenic is a word that some of they know, but they just know the water quality is bad. So one of the main findings of this questioning is to see that the people they drink purified water, but they still use tap water for cooking. And we think that's the main problem, the still use of tap water for cooking. Yeah, and so we began to ask what kind of activities we can bring them to explain the problem. The next one, just to finish this part. So we began to training the people to train teachers, the mothers in the school. They are mainly the mothers who they take this role, and so we began to produce some materials to explain for the children through games. Playing is the best part for the children to learn, and so we designed some games for them to play, and in these games we introduce the information about the quality of water, what is the arsenic, what are the problems are from arsenic, and what they can do to avoid this problem. So this is a pilot part of the program, and we hope to do the rest until along this year. Yeah, I think that is just the conclusions. So the next one. So for this part, arsenic, uranium, arsenic and fluoride, and now uranium are ubiquitous contaminants in groundwater in the comarca, and we have a main health concern in this part. The sources for these contaminants are not natural sources. That is the felsic magmatic rocks, and the population in rural communities drink mainly this purified water, but they still use tap water for cooking. And we think that through risk communication programs, we can help to reduce the exposure for these contaminants. So thank you for hearing, and I give you the words to Virgilio from the University of Yucatan. Thank you.
Thank you, Dr. Castro. Can you hear me?
Yes.
Yes, okay.
Yes.
Thank you, Dr. Castro. And okay, I'm the last one. So my talk is about the pesticides in groundwater and urine of inhabitants in La Region Lagunera, Mexico. Next, please. A brief background to understand why pesticides are important to consider in this research is that actually La Comarca Lagunera or Region Lagunera is one of the most important industrial and agricultural hubs in the north of Mexico. Actually, a lot of different kind of products from farms, such as alfalfa, corn, sorghum, or melon, that is the main export product, are produced in the farms in La Comarca Lagunera. So that means that because of the variety of the products, we have variety of pesticides that are used to protect crops. For example, DDT is one of the most important pesticides used in La Comarca Lagunera. It was introduced in 1940s, but was banned in 1990. So 33 and 34 years ago. Now we have a different kind of pesticide used in Mexico and in La Comarca Lagunera, of course. Some of them are glyphosate, paraquat, and 2,4-D, for example, for weeds. And about glyphosate, there is something interesting. Glyphosate is one of the most pesticides used in Mexico. However, glyphosate is not regulated in Mexico. No regulations are about glyphosate in Mexico, in water, in soil, anywhere. So, however, that means that, that means that you can buy pesticide anywhere and use pesticide if you want in your background if you want, in your backyard, sorry. So due to this, next please. The objective for this part of the research was to evaluate the organochlorine and organophosphate pesticide presence in groundwater in La Region Lagunera and urine of inhabitants of the region. As Dr. Castro said before, groundwater is the main source of water in La Comarca Lagunera for many, for people and even for industrial activities. So that's important to know what happened with water related with pesticides. Next, please. So now I want to share with you some relevant results. We work with 38 wells. The 38 wells, the wells that Dr. Castro showed before, well, we work with 38 of these wells. About DDT and DDE, well, how I said before, DDT is one of the most used pesticides in the history, but was banned in 1990s. So that's a surprise that nowadays we detect DDT and the main metabolite DDE in groundwater. Actually, the graphic to the left show that most of the wells, each bar is a well, most of the wells presented DDT and DDE. And to the right, we can see that most of the wells used for irrigation, 82% of wells are used for irrigation, presented DDT and DDE. And about the wells used for drinking water, we have some wells used for drinking water, 2 wells presented DDT and 4 wells presented DDE. These 2 compounds are considered very toxic to environment according to national and international regulations. So, but the fact here is why DDT is still detected in water. It was banned 34 years ago. Next, please. Well, the last one is lindane, specifically the gamma lindane. This pesticide was detected in 8 of the 38 wells. 5 wells used for irrigation presented lindane, and 3 wells used for drinking water presented lindane. This pesticide is highly toxic, and according to WHO, is even considered as carcinogenic to humans. According to the guideline value, the reference value, so the concentrations were under the limit. However, we did a more specific analysis between the relationship gamma lindane and alpha lindane, and we observed that the presence of gamma lindane in drinking water, in the wells used for drinking water, is a recent exposure. So that means that this pesticide is widely used in La Comarca Lagunera, even in areas where there are some wells used for water supply for population. Next, please. Well, about these 3 organophosphorus pesticides, ethyl, methyl parathion, and malathion, well, we observed that ethyl and methyl parathion were detected in almost the wells, and malathion just in the 34% of the wells. Malathion is one of the most pesticides used in Mexico. So to the right, you can see a graphic. So I want to show you that actually methyl parathion was detected in almost all the wells used for irrigation and all wells used for drinking water. About these 3 compounds, Mexico doesn't have regulations. So that means that we don't have a reference value, but according to other organizations, such like WHO, so the concentrations are below the limit. However, it is important to say that these 3 compounds are not regulated in Mexico, and one of them, methyl parathion, is widely used in agriculture. The next, please. Now about glyphosate and AMPA. The AMPA is the main metabolite of glyphosate. Glyphosate is widely used in Mexico, and how I said before, is not regulated. We found that 8 wells presented AMPA. Glyphosate was not presented in any well, and this is because the chemical characteristics of glyphosate and the half-life of this compound is several days, 3-4 days, but it transforms to other compounds such as AMPA, and is really toxic and stay in the environment for a long time. So we found that 7 wells used for irrigation presented AMPA, and 1 used for drinking water presented AMPA. How I say, we don't have a reference value in Mexico, but according to the international regulations, so the concentrations were below the limit, and according to the IARC, these 2 compounds are considered probably carcinogenic to humans. The next, please. Well, now it's about the presence of pesticides in the urine of people. We work with 100 samples of urine for people, from people to the Comarca Lagunera, About glyphosate and AMPA, we found that glyphosate was not detected in urine, how I said before, because of the chemical characteristics of this compound. But AMPA was detected in urine in 38% of the urine samples. To the right, you can see in the graphic in the yellow columns is the total of people classified according to the range of the age. And in dark blue, the people in that classification that presented AMPA in the urine. Here it's important to say that just 2 people, according to the surveys that were applied, say that use pesticide because they are farmers. But what about the rest of the people with AMPA in the urine that they are not farmers? Before, I showed you that one of the wells used for drinking water presented AMPA in high concentration. So that means that probably, how Dr. Castro said before, for pesticide, as for arsenic and other compounds, maybe the way to go into the body is because of the water. The next, please. Well, I want to show you some additional results. This is because according to these results and before I show you is my final conclusion. So we have some results about the presence of pesticides in blood serum, human blood serum, and most of the pesticides that previously I showed you were presented in the blood serum, and AMPA was the pesticide with the highest concentration in blood serum. So what that means? What that means that actually we have pesticides in water, we have pesticides in urine, we have pesticides in blood serum. So we have a concern about pesticides in la comarca Lagunera. That will be my main conclusion about this. The next, please. And here I just want to share with you that this project was developed always looking for a social impact, a positive social impact. As the other presentations, they show that we have some community work. It is important to share the results with the community to know they have they need to know what is the situation. And actually the population help us to develop this research about pesticide. We designed a guide to support farmers in the proper handling of pesticides, the proper way to handling pesticide residues, and of course the personal protection for farmers and other aspects related with pesticides. So we designed this guide to help farmers in the area. Next, please. And finally, what are the future perspectives about pesticides? Well, it is important to expand monitoring of pesticides in water, especially glyphosate and AMPM, because all the things I said before in wells. And for this research, we only monitored 8 wells used for drinking water. So it should be interesting to monitor more wells used for drinking water. The presence of pesticide in the urine and another compound that could indicate health problems. Previously, Dr. Gonzalo said that actually arsenic is present at, or is detected, sorry, in the urine of people. So we have pesticides too. We have 2 very toxic compounds in the urine of people. So that's interesting to expand this monitoring. Finally, it is important to promote public policies at all levels in Mexico, specifically for the Comarca Lagunera, related to pesticides. How I said before, more of the pesticides used in Mexico, such as glyphosate and the other like malathion and others, are not regulated in Mexico, but are widely used. So it is important to promote public policies related with this, and of course to study the possible relationship between compounds, the different compounds that we detected in urine and in groundwater too. And finally, I just want to say that I hope in the future to be able to share new results related with this research and which measures are being taken for locally to solve these problems that we presented today. Thank you very much.
Thank you very much indeed, all of you. All I can say at the end of that is, wow, what a great piece of work. That's fantastic. Thank you so much for sharing it with us. I've got thousands of questions, but if there are other people who would like to ask questions before I go, that would be great. So if you could, any hands going up?
I can stop there to share now.
That would be brilliant if you don't mind. Okay. Anybody wanting to ask anything? Okay, one of the things I really liked was the degree of cooperation across several areas of investigation that gives you such a phenomenal outcome, but also raises so many questions behind it as well, and the possibility of helping so many people with the information that you've brought out there. One or two things. How easy was it to get ethical approval for the studies? Or is that not required in Mexico? You just put the study together and you can go for it.
Well, maybe I can answer that. So, there are ethical committees. Our university, the University of Durango, has one that involves medicals, MDs, and also people from the community, religious people, and so there's people that represent the community, and all the research that involves humans need to be presented at this committee. At the beginning of the study, we send the project to them, and they revise it, make some suggestions, we answer the suggestions, and they finally approve. We have an approving for the project, and also they approve the consent letter of informed consent letter that we ask for the people. So that is, and in Mexico, there is a law, the health, the Ministry of Health has a law for human research. So these aspects are covered.
Okay, thank you very much indeed. I asked the question because as soon as you start talking about involving people and you're actually taking body tissues, and I would include urine in that, then it starts raising those questions of ethics, it being involved in that. It's actually also made me wonder whether or not there is the possibility for you to do retrospective studies, because one of the graphs which you showed with the I think it was from one of the pesticides ones, that was the increasing quantity of pesticides the older in the older generation. So as you age, the concentration increased. And is it possible to do a retrospective of whether there's an increase in disease in those people as well? So at what point that the various diseases start to kick in? Is that possible? And it's a whole different study, but is it feasible?
Well, we can have two kind of retrospective ways. And in health, this is the bigger study that we made in people. But we have more than 20 studies about 100, 300 people. So we can have, and we are writing that, the historic timeline of arsenic exposure people. But I understood that Javier Castro asked to, Dr. Javier Castro asked to Water Commission in Mexico about the former studies on arsenic concentration. They have a large story. We are constructing, I think Javier Castro is constructing, maybe he can talk more about that, the history of arsenic in water in the Region Lagunera.
Hey, thank you. That sounds fantastic. It's good to be able to know that can happen.
No, not for this presentation, but you are working
No,
on.
no. I realised. Yes, it was a question of in principle. Thank you. You've absolutely answered my question. And actually, that my other question overlapped with that as well. Anybody else want to come up with anything? Yes, I thought, Ali, because you might have something somewhere. Go for it. You'll need to unmute. That's it.
Right. First of all, congratulations. It was an excellent study, and sorry I missed the first part, the 15 minutes, because I had it was something wrong with my computer. Well, you have shown very nicely the society part, which was good, really, because I mean the results are not so good for the people there. And one thing that I'm worried is that the people, you said that they drink bottled water, but they still use water from taps for cooking, which again is dangerous for their health. What is there any sort of let's say government sort of will to sort of find other sources of for their tap water?
Yeah. Actually, there is a big program from the government to bring water from a big dam. So to superficial water, to bring superficial water to the people from a dam from the mountains to the west. This program is what started 2 years ago, but the point is that there is not always water on these mountains. And so last year was a very, very dry year, and there is not enough water for the people. And so the reliance on groundwater remains there. That's the point for the Comarca Lagunera. And this program from the government will bring water mainly for the big cities, Torreon and the surroundings. And so they will have water with better quality, but these vulnerable communities on the rural area, they are the main, the people who stays on the background on receive bad water on probably for the future. So that's why we started these programs with the rural communities. They need to know that so that they protect themselves.
How many thousands of people are they living in this area, the rural part?
And in this area, there are about 1.5 million people, and in the rural community, so the rural area, there are about I don't know, probably Gonzalo knows better, but I think it's about 300,000 people.
Yes, that's right.
Because I was thinking if they can bring, I mean, they have, let's say, small reservoirs in each village or town, and then they bring clean water with tanks, something like that. But it's going to be costly, but I think health is more important than cost.
Yeah, that's what we're trying to bring to the people. And so one of our collaborators, I don't know if she's there, but she plans this year to start also with to bring to the same we can say it so in the rural communities the women are the power, yeah. In the rural communities, women are the power, how everything works, yeah. And so we're bringing this information to the women. So also a financial program, how that they understand what that means for their finances, for their finance, to that what it means health and a healthy life is for the long time feel better to invest a little bit more money in water than after a few years to have to invest in medicines. So that's part of the ideas to bring to the people, and we will start this point this year.
Thank you. That's precisely the point I was going to follow up with, is about putting the cost benefit analysis in there, isn't it? Of the cost of trying to sort somebody out who's got diabetes, as opposed to the cost of the clean water in the first place. There's just no contest, but it's trying to get the mindset change within the powers that be that have the ability to make the policy change to bring that about.
Yeah.
I think it's a
Gideon,
really important study you've done. Sorry, Alikos.
I think we should start using not cost benefit, but benefit to cost.
I agree.
You're right.
Absolutely agree.
Yeah.
Are there any further questions? Because I'm very aware of the time, and I'd like to say thank you to the speakers for being free with their time and giving us some extra here. Any further questions?
A quick question from me.
Yeah.
So thank you very much for a very interesting presentation. Did you consider hydration factor when measuring the arsenic in the urine? Because I've previously done a fair bit of urinary biomarker work myself, and that's something we look at with creatinine and osmolality as a measure of accounting for hydration, especially where we've worked previously in very hot environments. I just wonder if that's something you've accounted for in this study.
Yeah. Yes. We have experience for more than 20 years, and we have made some adjustments for urine concentrations like density, like creatinine, like osmolarity. So, but after the experience and also from the several studies, arsenic is also nephrotoxic. So sometimes change the arsenic excretion and also the depuration, the clearance of creatinine and density. So we published in the 2009 or 10 a study where almost all the methods to adjust arsenic or other metals in urine did not change a lot the prediction possibilities to find the relation between the metal concentrations in urine and adverse effects. So for that reason, we use the total concentration, but we have made creatinine in all the samples. So this is the cheaper way to adjust arsenic urine concentration, and we are going to, and also we make density of the urine. So when we publish the results, we will have the results of total arsenic and also the arsenic adjusted by density.
Great, thank you very much.
I would like to make a suggestion because you have a very well-documented case study which goes across. Is it possible to sort of write the a few papers on each aspect as you present them, and also what you have done with the communities and publish them in the journal of the society, and also make available the raw data? It's important for the teaching purposes, in my opinion.
Yeah. Yeah.
Excellent. I think I agree with you, because I think there's actually almost a special paper for this, isn't there? Just a justification for there's so much data in there. There's so much information.
They can have 2 or 3 papers or 4 papers.
Yeah.
easily.
Yeah.
Well, thank you again for a really interesting presentation, and for being up so early and being prepared to share your time with us. I really appreciate it. On behalf of all of us, a big thank you. And we hope to see you in Belfast. That's a great idea. Fantastic. Take care. Thank you.
Okay, take care too.
Bye.
Ciao, and thank you, Julian.
Bye, and thank you very much for your time.
Thank you.
Bye-bye. Bye-bye.
Ciao.